Hi, welcome to everyone. It's the third video regarding automation and control system laboratory. So in the last two videos, we discussed about the introduction of fluid power system or hydraulics and pneumatics. We discussed about the advantages, disadvantages, why we need pneumatics, why we need hydraulics, applications. Likewise, we have discussed so many types, the basic components about the hydraulics and pneumatics. Today, in the continuation of that one, we are going to discuss about the software what we are using to simulate the circuits, how to develop a circuit, how we can simulate it before going to implement the circuit. Okay. Today we are going to discuss about fluid sim, first of fluid sim software. We are going to introduce in this video we are going to introduce this fluid sim software, how to draw the circuits one by one we will discuss. So what is my fluid sim software? So it has been the leading circuit design and simulation software for pneumatics and hydraulics for more than 20 years. It has all the components for designing hydraulics and pneumatic circuits. It helps to understand the design circuits work properly, whether it is working properly or not before going for real world implementations. Also, it is very useful to understand the concept of fluid power automation. Easy to understand. So those are all beginners to know about the automation. They can use this fluid sim software to understand the concepts of hydraulics and pneumatics. Okay. In fluid sim software, it permits the creation or design a circuit and simulate the circuit in the following fields. So not only for pneumatics, it's going for electro-pneumatics, vacuum technology, electrohydraulics, mobile hydraulics, electrical engineering, or electronics. It is referred as fluid sim P, fluid sim H, fluid sim E. Now the major feature of fluid sim is its close linkage between computer design functionality and simulation. There is a close linkage between computer function and simulation. So first we'll see about the fluid sim software. Before entering into that software, we can have small introduction about all the elements what we have in the software. So as already we know the basic components of pneumatics. In this pneumatics, we have supply elements, control elements, actuating elements. So first we can see the supply elements of pneumatics. So many supply elements are available. You can see the first two symbols in that these two we can use for the air supply. If there is any variation in the air supply, we can use this symbol. This is a symbolic representation while we are going to design a circuit in a fluid sim software. Then second one is air service unit. A simple air service unit means you can go for this symbol. If you need attached unit means you can have a pressure gauge and a pressure relief valve. With this unit, we can call as a extension unit. Similarly, we need some extension unit with filter control means we can have this symbol. We need more connections. We want to get n number of connections. Then we can go for manifold. Then reservoir you want to mention means you can use the symbol reservoir. Then automatic drain filter, air filter, the symbolic representation, manual air drain filter, manual drain, automatic drain, then lubricator is mentioned like this. Okay. So you can see this air unit actually in general in industries or in laboratories we can see air unit, FRL unit we can see. Yesterday also we have in the previous video also we discussed about the basic components of pneumatics. There we can see the FRL unit, filter, regulator, and lubricated. So this one mentioned the filter. This is the regulator. Another one, iPhone, you have to add for the lubricator. Okay. The next, it deals with the cooler, air dryer available in the compressor. Then how we are drawn the circuits. We are using a pneumatic continuous line and T connections we are having for joining 2 3 lines. Also, we have dryer. Three different types of dryers we are having. One we are having absorption, adsorption, and refrigeration. So three different types of uh, air dryers we are having. In absorption is a chemical method. It's a chemical method. It has a gel. It absorbs the moisture content. Similarly, in adsorption also we are using a salt content. Here in adsorption we are using salt. You have to absorb the oil, air moisture content. Then you have to go for the second one. So this adsorption method we are using. Third one, if you want a very less humidity level, means you can go for air dryer refrigeration method. You can go. So one by one we will see in this coming time. So air dryer adsorption means it's a equivalent lowest equivalent dew points up to 90 minus 90 degrees centigrade can be achieved by means of adsorption drying. Here the compressed air is passed through gel and the water is deposited on the surface. So we are calling it adsorbed. Then absorption means a chemical process. The moisture compressed air forms the compound with the drying agent. So drying agent we can use a salt. This causes the drying agent to break down. It is then discharged as a fluid to the base of the tank. The drying agent must be replenished at a rate which is dependent on the compressed air temperature, water content, and flow rate. The third one is air drying the low temperature. So it's a refrigeration method. If the dew point more, the water will condense and reduce the amount entrapped in the air. So if your dew point, the lower the dew point, more the water will condense. So then we can use the refrigeration method. It is possible to achieve a dew point of between 2 degrees centigrade to 5 degrees centigrade. Okay. So these are three methods we used in the secondary air processing unit in a compressor, calling absorption dryer, and refrigeration dryer. So the second one is control elements. First one is supply element. Second is control element. Control elements we have different valves: direction control valve, flow control valves. We are having in direction control valves. We are having different types based on its number of ports and number of positions. So, for example, 2 by 2 valve means 2 position, 2 ports we are having. 3 by n valve means 2 position. That means 2 position we are having. 3 ports we are having. Then 4 by 2 means 4 ports, 2 positions we are having. 5 we are having. So 5 ports, 1, 2, 3, 4, 5. 5 ports with 2 positions. Then 6 by 2 means 6 ports with 2 positions we are having. Similarly, we are having 8 by 2 also we are having 8 by 2 way direction control also there. 8 ports we are having. Okay. These are all the normal valves which is having the moving element like this. Two different positions. How it is actuated. So mechanically we can actuate. So 3 by 2 roller device we are having as well as idle roller devices we are having. So roller limit switches we are having, idle roller, idle return roller device also we are having. Then similarly proximity switch solenoid operated systems we are having with spring return. Then return switch also we are having. Then push button also we are having. So these are all mechanically operated direction control valves. Similarly, you can see 3 by 2 valves, push button with return, with mechanical manually operated pneumatics. So n number of symbols are available for the components. Different valves we are having. solenoid, then electrical valves, pilot operated valves, then manual operated, mechanical operated valves. So these are all the exhaust elements. So we are having silencers, SOS symbol. Usually we are using this in the circuit, then fitting, blanking. So just like that we are having a number of symbols. Okay. The next one is actuators. Whether we are having different type of actuators: single acting, double acting with the double end rod, double acting with non-adjustable, double acting with adjustable cushioning, single adjustable cushioning, double adjustable with both direction we are having cushioning. Then rotary also we are having one direction fixed, one direction variable capacity, both direction variable capacity, limited travel rotation, both directions. So, then special valves are there: check valve, then shuttle valve, pressure valve, and exhaust valves also there. So these are all the symbolic representation of all the valves. Okay. So now what I am planning to, you can open the software, Fluid Sim software. It's version 6. Here we can see all the symbolic representation. For example, we are having pneumatic components, electrical control systems, and electrical control with ANSI symbols, digital, etc. So it's a Fluid Sim pneumatic software. Okay. So when you click this one, you will get first one is actuators. All the different types of actuators are available. Single acting, double acting with the cushioning or variable, double acting with the double rod, linear drive with. So just like that we are having. So if you want, you can linear drive with solenoid coupling, then linear drive with the pneumatic space fitting adapter, then single acting cylinder, then single acting cylinder with the spring return. Just like that we are having a number of linear actuators as well as rotary actuators we are having. So whatever you want, you can. Then second one tells about supply elements. So whatever we discussed earlier. So we are having compressor, manifolds, air service unit, air filters, then variable compressor, manual filter, dry air, drainer, lubricator, etc. We are having a number of. Then silencers also we are having. Open, exhaust fitting and blanking also we are having. Okay. Then we are having mechanical operated direction control valves, pneumatical operated valves, then solenoid operated valves, then flow control valves, different types of flow control valves we are having. First one is throttle valve, throttle valve, check valve, then throttle valve, check valve, different. Then we are having throttle valve, check valve, two check valves, two. Then two pressure valve, shuttle valve, then quick exhaust valve, then pneumatic timer normally closed, pneumatic timer normally open, nozzles, variable throttle valve, then spring loaded check valve, then here we are having a variable office. So just like that, a number of special valves also there. Then pressure control valves also available. This one is pressure control with manometer, pressure control with reducing valve, pressure control with reducing valve, pressure reducing valve, then variable pressure reducing valve, closing pressure compensator, just like that. A number of pressure control valves also available. Then measuring instruments you want means you can measure the pressure gauges are there. Then next one valve groups we are having different valve groups. So stepper module, type TTT, TAB, two hand control block, shuttle valves, time delay valves, timer delay normally closed just like that. Then in addition we are having vacuum technology valves, proportional valves also available. Electrical, these are all later we will discuss about all this we can see. So now we can see how to draw a circuit. So what are the basic components in pneumatic system? So initially we need a supply element. So which supply element we have to add? So supply element we add. So we can add a supply element. You click, just click and move it. You can have it. So if you want to add more means you can copy and paste it. And wherever you are pasting, you will get. Okay. Then if you want to keep this means you can keep. Otherwise you can have this symbol also. This also supply element. Any variable means it is this three. Any one from these three you can choose. Okay. All are related to compressor. Okay. All symbols related to. Then we have to go for a filter FRL unit. So we can have an FRL unit. So we are having a supply unit, then FRL unit. Here it is filter and regulator, no lubricator. Okay. Then we can go for actuators. What type of actuator? First we can go for a single actuator. Then we can go for a valve. We need a valve. We need a valve. So we can go for control unit. So already mechanical operated valves you can choose 2 by 2, 5 by 2, 4 by 2, just like that. Anyone you can use. Hmm? So we can use any one of the valve. One of the valve we can use. Then one switch you can use. Okay. So now one by one we'll see. First you can go for actuator elements. So just double click here. So you can see the identification or labeling. You want to label it. So you can have it. You want to label it means you can, for example, we are going to keep this circuit as S1. So you can keep. Then it's a single acting cylinder. You can display it. You want to simulate any values depends upon position, velocity, acceleration, force. You can change this one. Now it is very important. We have to configure the cylinder. So it is a single acting cylinder. So there is no cushion. If you want, you can add a cushion. If you want an adjustable, you can add. Self-adjusting also you can add. Or cushioning also you can add. So if you want, you can add all this. Okay. Even single acting we are having, you can change that single acting. Okay. So one side is closed. Then force profile also there. It depends upon your applied force. It will get changed. Okay, constant force or other constant force we are using. Usually we are using. If you want, you can add or you can change this. Then external loading conditions. Based on the loading condition, you have to change for the simulation. Then we go for actuating label. So we can go for actuating label. It is we have to mark cylinder A. We can do so A minus. It starts with the 0, then A plus. It starts with 100 and do 100. Okay. So or anything you want to change, you can add. So now you can see here it's a single acting cylinder. Hmm. So it's a single acting cylinder. Our project is S1. Now we can go for the valve. Here also double click. There also we can see the configuration value. So it is pneumatically operated, spring return. These positions you want to change means you can change the positions. Any positions you want to change, you can do. Okay. This also you can do then simulated values, component, so everything will be there. Here also you can have D, C, E, 1. Everything will be displayed. Okay. Here also it is displayed. You can go for next wall. Here it is also a direction control valve, but it's a switch we can. So we can have it's a push button switch. Push button. So P, then you can have this. Okay, simulated values, configure values. If you want to change, you can change. Okay, so it's a procedure. When spring return, it's not pneumatically, it is manually operated push button values. Okay. Now, if you want to do anything here regarding this FRL, so FRL you can F sorry, it is filter regulator FR. Yes, okay. So simulated values also. Yes. Here also you want to do anything means you can add say compressor or manifold. You are getting a supply element, so compressor. Supply. Any variations you want to do with the pressure, flow rate, volume, then you can that also you can. Okay. So now you connect one by one. So press it and join it. Then we press it and join it. Small change. So here you can have this. Here you can have this. Okay. Then from here we are giving signal to the DCV. From there we are giving signal. So in this wall, if I am giving like this means you have to block here. So we can't use for single acting cylinder, we can't use a 5 by 2 wall. Understood? For that purpose only I added. So what you have to do means instead of 5 by 2, you have to go for 3 by 2 walls. So we can remove this and directly you can do. Okay. So now we are connected a single acting cylinder with a push button switch. Single acting. Our aim is to operate a system by using a single acting cylinder. So now we go to the home. There is a start button. So press it. So whenever we are pressing the push button, immediately it will extend. So because it's a spring return. Now understand? Understand? I think you are all very familiar with these symbols. So if it is a single acting cylinder means we can't go for a 5 by 2 parts. So it is better to use a push button. That means it is a direct acting cylinder. Indirectly also we can do, we can have another one 3 by 2 valve here and we can activate that also. If it you want means you can do like that. Now instead of this, stop it. Now I am going for a double acting cylinder. So we can move it and we can go for a double acting cylinder. So what I am doing is double click. We'll go for a double acting cylinder. You can go for double acting. No adjustable, no cushioning, no need. You can move it and you can go for a double acting cylinder. So simulator I already explained. So you can go for cushioning and adjustable. Then actuating labels you go there. So A, minus A plus. It starts from 0, end with 0, 100. Want to do it here means you can have a double acting cylinder. Okay, so now it is active. Now, if you want to activate a double acting cylinder means we have to add a 5 by 2 wall or 4 by 2 wall. We have to add a 5 by 2 or 4 by 2. So, for example, you can have this one 4 by 2 wall. Okay, so now double click. We will configure the cylinder. You can go for pneumatically operated both sides. Okay, so now we can connect. From here, you can connect this. Okay. This one you have to give exhaust. So double click, you'll get exhaust. Otherwise, we don't operate. Okay. Now, what is missing? So we need a signal to receive all this. Okay. So we are adding a 3 by 2 wall there also. So we can have a 3 by 2 wall. Rotate it. Rotate it. Rotate. Double click. Go for configuration. It's a spring return. You can have a roller. Okay. Here you can double click. You can use plus. Double click and mark it. Okay. Then here you can go for okay. Now this signal we have to give it to. So we want to change this line in different color means you go to the double click and go to the drawing properties. You change the line into dotted line. You want to change the line width means you can increase the line width. Or you want to change the color, you can change any color you can change. Okay. So now I think all the connections are given. You can check whether this is working or not. So start. So when you are going to press it immediately, so what will happen? I am pressing extension across only retraction. We are getting the signal. Okay. So I think you are all understand about the basic components and the symbols and how to draw a circuit in Fleet Sim software. So now we will go for the next experiment exercise where we will see the continuous activation. Okay. So thank you very much for your patience.